In this video, we're going to take a look at the Model Mania Design Challenge from 2014. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are given a drawing like this and they're tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're finished, they're given an additional drawing with a series of changes and tasks to perform on the part. But let's go ahead and take a look at this drawing and look at how we'll create the first phase. Like many of the other videos in this series, this top view really lends itself well to using contour selection, meaning we can create a lot of geometry in one sketch. But then looking at section AA, we can see that geometry is used quite differently in several cases. Also, the isometric views show this clearly. There's a bottom kind of circular shape with these three holes that go through it that appears to be shelled out. Also, looking at the top isometric view, we can see that some of the other geometry comes up off from that top surface and is also hollowed out on the inside. For this, we're going to look at a unique use case for using multi-bodies. So let's dive in. I'm going to go ahead and start sketching on the top plane. And as I just mentioned, we're going to use contour selection. So I'm going to draw a lot of the geometry in this sketch. For the circular pattern, I always like to create a construction circle that's going to represent that bolt circle diameter. I'm going to go ahead and select this and change it to construction geometry, though it's not absolutely necessary to do that. Additionally, there's several 26mm holes, and you'll notice that there's also an 18mm radius that goes around this. For this, I'm going to go ahead and just draw a circle out, and I could type in the 36mm diameter. But what I want to show is that you can add a dimension after the fact and just place it, and then right click on that dimension and you can change it to a radius value. Likewise, if it was a diameter, or a radius, you could change it to a diameter. Then I just need to double click on this and we'll change that to the appropriate 18mm value. Keep in mind, you could have typed in 36 and you would have gotten the same results. At this point, we do have three instances of this, and normally we would use feature patterns, but circular patterns in a sketch is another way we can accomplish this. But because it is a sketch, there are options for things such as adding a radius and an angular spacing between these and an instance count like the feature pattern. Notice I'm going to leave these unchecked, and when I do, the geometry stays blue, meaning it's underdefined. It's because we didn't add the angle between them, or any of the other relationships. But there is a point here in the center of the pattern, and we can snap this to the center of our bolt circle, and that way whatever changes in the instance count, you'll notice that everything updates from the center of the part. That makes it really easy to go back later and maybe make changes to it. Finally, I want to join these circles together using some tangent lines. Clicking and dragging with a line tool off of an arc makes it easy to capture that tangent relationship off from that arc and snap tangency to the other arc. We're going to go ahead and do the same thing down on the bottom here and draw that last line. We have all of our geometry. I could trim these circles. I'm not going to, and I'm going to show how that will impact us when we go to create these features. So at this point, we're going to go ahead and extrude this. And I'm looking at the drawing, I want to start with this bottom region shown here in this lower isometric view. Notice that it's extruded out, but there's also holes with a wall thickness around them of 3mm. So in SOLIDWORKS, we're going to do this using contour selection. Let's go ahead and quickly capture that depth. It's 15mm, so you can clearly see this. What we're going to go ahead and do here is I am going to reverse the direction and I'm going to select a few more contours. Notice I'm going to select these circles. When I do this, we create the disc with the three holes going through it. To quickly capture that common 3mm wall thickness, shell is a great feature to do this. And I'm just going to go ahead and select the bottom face and notice how it gives us what we saw in the drawing minus those fillets on the inside, which we'll add later. So let's go ahead and look at adding the top extrusion. We're going to reuse that same first sketch. I'm just going to highlight it out of the feature manager tree and choose extrusion. And like before, we're going to select some contoured regions. Now notice in this case, because I didn't trim these circles, how I have to select each one of these regions, and then I'm going to go ahead and select this internal region as well. Additionally, we need to capture the appropriate height for this. Now looking at the drawing, we could simply subtract 15 from 35 and know what the depth is, but we always want to drive this off from the bottom surface. In SOLIDWORKS, you can do this by choosing the offset from surface end condition, and in this case we'll choose that bottom surface. we'll go ahead and enter the appropriate offset value of 35 millimeters, and looking in the graphics area we can see that the arrow is pointing in the wrong direction, so we'll simply flip that around. Now at this point we're also going to want to hollow this geometry out 3 millimeters. So here's where things get interesting. I'm going to uncheck the merge results option, and when I do this, SOLIDWORKS creates a multi-body part file for us. One of the advantages of working in multi-body parts is the ability to perform body-specific operations such as a shell just to one body. So we're going to create a shell to this body, and I'm going to use select other to grab that bottom face over here. And when I press OK, notice that it shells out just that region that we created. Now, we still have a problem. These two bodies are separate, and we want to join those together. One of the best ways to do this is to simply select the bodies out of the Feature Manager tree, right mouse click, and choose the Combine feature. Combine allows you to perform Boolean operations such as adding the geometry, subtracting one body from another, or finding the common regions between them. We're going to add in this case. When we do this, we can see we have pretty close to what we're looking for, minus a few of the fillets that need to be added to this. So at this point, there's several fillets that we need to go ahead and add. They're all 3 millimeter fillets, so I'm going to go ahead and do this. Now I'm going to use a combination of face selection and edge selection, and we'll show why. If you've watched my previous videos, you know that I like grabbing faces because it quickly captures a lot of the geometry that oftentimes needs to be filleted. Again, we'll select this face on the inside of this pocket, but notice when I, oops, no, let's not grab that edge. When I grab this face, it doesn't solve. It's actually trying to fillet every single edge on the side of this. So in this case, I'm going to go ahead and just select an edge, and then we're going to use the quick pop-up that appears to grab the connected end loop types. Finally, there is one more fillet we could go ahead and grab on the outside here, but I'm going to create that separately. And I am intentionally doing this to show you the power of reordering features later on when we make the design change. Keep in mind, you could add that as one feature, though the change later on will probably take a few extra steps. Oops, and I did miss one edge here. We do need to grab this surrounding edge in this case, and I'm going to go ahead and press OK. Finally, if you look in the lower right hand corner, you can see that there is a material specification of plain carbon steel. To do this, we're going to right click on the material node in the Feature Manager tree, and we could either select this out of our favorites or choose from our library of materials we have available. In this case, we're going to go ahead and simply select it. Remember, selecting a material does more than just change the appearance color of the part and the crosshatch in the drawing. It also specifies the physical properties of the part as well, including things such as the weight and the strength should we ever need to perform a simulation, which coincidentally we will need to do in Phase 2. Speaking of, let's go ahead and look at the Phase 2 drawing. When we look at the Phase 2 drawing, we can see that there are actually very few changes to the part, but the one change we make drastically impacts the overall look and feel of this part, changing that outside diameter from 100 millimeters to 84 millimeters. Additionally, you will notice that we do need to use Simulation Express or SOLIDWORKS simulation to determine the factor of safety on this part. So let's go ahead and go back into SOLIDWORKS, and let's look at that first change that we need to make. We're going to go ahead and change this diameter from 100 millimeters to 84. Now when we do this, you'll notice that this second fillet that we created does fail. And going back to the drawing, you will notice on the top view here, or the section view, you can see that there's a very specific way that that fillet is supposed to look. So let's go ahead in SOLIDWORKS and look at how we can solve this. I wanted to emphasize the importance of order of that you create your features. And to do this, I'm simply going to reorder these two features. And when I do this, now keep in mind some of these edges may have disappeared. Let's go ahead. We're going to reapply these edges in this case. And we're going to press OK and simply redefine that. Notice that because this fillet happens before the rest of those, we're able to get what we're looking for. If we reorder this, we don't get the desired effect in this case. So keep in mind when you reorder your fillets, it will change the way that they could show up at these weird intersections like this. Other than that, there weren't really any changes that needed to be made to this part. So let's go ahead and dive into working on the simulation of this part. To do this, I'm going to go ahead and use Simulation Express simply because it's found in every version of SOLIDWORKS. Simulation Express is wizard-based, which means we have to walk through a step-by-step process. If we look at the drawing, you'll notice that we need to fix the two lower cylindrical faces. So I'm going to go ahead and add a fixture. And in Simulation Express, the only type of fixture you can create is fixed. So this makes this easy for us. We're going to go ahead and fix these two cylindrical faces and press OK. Additionally, we could have added those one at a time, and we could have added an additional fixture. But I'm going to go ahead and move on to the next step. And at this point, we need to apply a 10,000 Newton load to this top cylindrical face. More specifically, notice when we apply that load, it gets applied directly out. We need to apply this in a specific direction as shown on the drawing. To do this, we're going to choose the Select Direction option from the Property Manager for this. And I'm going to go ahead and I'm going to grab one of my planes out of the Feature Manager tree for reference. Now notice the arrows are pointing in the wrong direction. So we're going to go ahead and reverse this. And we also need to apply the 10,000 Newton load in this case. So we've gone ahead and added this. Let's go ahead and press OK. We could add additional forces and pressures, but let's move on to the next step. Here you would have the opportunity to specify the material if you hadn't done it before, but because we did, notice it captures all the important information. Let's simply move on to the next step and run the simulation. Give SOLIDWORKS a few seconds to quickly mesh the model and solve the simulation, and you can see how the force is acting on this part. This is what we expected, so we can go ahead and press yes to continue to look at the results. In this case, we're looking for the lowest factor of safety, which can be found in the text here over on the side. In this case, it's 3.51. There may be some tolerance based on your mesh density settings, but it should be right around that. Additionally, you can change the factor of safety results here. So for example, if you wanted to find particularly weak areas in your design, we could say, show me where the factor of safety is below 5. And this helps you find where those weaker areas are, but keep in mind a factor of safety is quite high. Additionally, we could also show the displacement of this part to understand how much it will deform or deflect in this case. Now keep in mind, because we are using Simulation Express, we're limited to scientific notation in millimeters in this case, but if we were using SOLIDWORKS simulation, we could change this, for example, to floating point decimal to get an easier to read number. So there you have it, the Model Mania Design Challenge from 2014. If you're interested in learning more about Model Mania, or more specifically SOLIDWORKS World, I highly encourage you to visit the link below this video or in the blog post where it's hosted.